So let's just rewrite this. Remember this d over d theta. This thing means I'm going to take the derivative of, and that's what follows. So I'm just going to take the time to rewrite this radical theta as theta to the 1/2 power. Now I can say the derivative is, and then I'll get 16 theta cubed, bring the 4 down, subtract 1 from the exponent, minus 1/2 theta to the negative 1/2. This one here, I'm going to take the time to rewrite it, so I'm just going to say equals, because it's still the f of x, and I want to make sure that you're separating the radical around each of those two terms, and then I'm going to take the time to rewrite this as a x to the negative 1/3, and then b x to the negative 4, and then plus the c. Okay, now I'm going to take the derivative. So now I'm going to say f prime of x equals, so I'm going to take the time to rewrite this root 16 as 4, and then taking the derivative of this, and maybe I could spend an extra step to rewrite that as x to the 3/2, but I'm just going to use it now. So 3/2 x to the, subtract 1 from the exponent, so you get 1/2. So when the number is multiplied times the x term, you just carry that number along. So I'll have plus a, and I'm going to bring the negative 1/3 down, x, and I'm going to subtract 1 from that 1/3, so I get negative 4/3. Plus, carry the b along, and then I'm going to, it's multiplied times this x term, negative 4 x to the negative 5. And then the derivative of this c term, since it's by itself, it's a constant, the derivative is 0. And it's okay right now, you could just leave it like this, but you could, you could fix it up if you'd like. Mostly I just want you to exercise your muscles of taking the derivative. So this one you must multiply it out. So you have to take the time to do that. So I'm going to say I'm going to take the derivative of, let's see, multiply these two things, and I get 12z to the 4th minus 20z cubed minus 6z, and then plus a 10. Now I'm going to take the derivative, so I carry the 12 along, take the derivative, and I get 4z cubed. Carry the negative 20 along, and I'm going to have 3z squared, right? Bring the number down, subtract 1 from the exponent. The derivative of negative 6z is just negative 6, because when you take the, taking the derivative, you'd carry the 6, and then here I have a 1 in the exponent, so I bring the 1 down, and I have z to the 0. So that's how it turns into just 6. So that's negative 6, and that's it. This one here, you must separate it around that subtraction in the numerator. So let's take the time to say pi x cubed over 3x minus e over 3x. So that's just a mess. So let's just fix it up. So y equals, so I see the number pi over 3. So let's just pull that off to the side. And now let's look at those two x terms. So these two x terms give me an x squared. You always want to end up with 1x to 1 power for each term. So this one here, I see the number e and the number 3, so e over 3, and then taking this x term and putting it in the numerator, that's x to the negative 1. Now I'm ready to take the derivative. So I say y prime, don't just say equal and keep going. Y prime equals, and I'm going to carry this pi over 3 along because it's multiplied times the x term, then take the derivative of the x term, so that's 2x. And then I'm going to carry this minus e over 3 along, and I'm going to take the derivative of x to the negative 1, so I'm going to bring the negative 1 down in the front. Oh, that's going to make it positive. X to the negative 2. Subtract 1 from the exponent. So this here, it's all just one big mess, so let's just pull the numbers. So 3e squared and pi are all numbers that are just multiplied times x to the 4th. Oh, let's go take the derivative. So if I said to find, if y was equal to 5x to the 4th, and I said find y prime, you'd say, oh, carry the 5, and then you'd get 4x cubed, right? This is the same thing, big ugly number. So y prime will be 3e squared over pi times 4x cubed. This one here, again, make sure you're simplifying it before you take the derivative. So if I take the 3 and cube it, that's 27. Multiply these exponents over, and then it'd be 36x squared. So let's fix that up, 27 over 36. And then taking these two x terms, subtracting, I get x to the 4th, right? 6 subtract 2 gives me the power of 4. All right, so then y prime 27 over 36 and 4x cubed. Again, we'll be simplifying as time goes on when we're doing things with these derivatives. For now, we can just leave it. So find the equation of the tangent line. So that means you need to find the point and the slope, right? That's supposed to be an m, right? The point and the slope so that you could put it into this to find the equation of the tangent line. So we're taking the equation of the tangent line at G at the point x equals 3. So let's see what they're telling us. Oh, look at this. They're telling us G of 3 is 5. Doesn't that mean when x is 3 that y is 5? It does. What does this mean? I even write it out for you. This means the slope of the tangent line at x equals 3 is -1. So that's your m. So here I have my point and my slope. So then I can just put it together. A different kind of problem where you're still finding the equation of the tangent line. So I need a point and a slope. So point, I'm just going to do first since I see this right here. So I'm going to plug 1 into the function. So I get 3 minus 4 plus a 3. So that gives me a -4. So my point is 1 negative, oh, sorry, I did that wrong. I get 6 minus 4, right? 6 minus 4, so that's a 2. So my point is 1, 2. So now I need to find the slope. So the slope of the tangent line is I'm going to find from the formula that tells me the slope at any point x. So first I'm going to take the derivative. So I bring the 4 down, so I'll be 12x cubed. And then taking the derivative of this term, I bring that 2 down, I get -8x. Oh, and the derivative of 3 is 0. Now I want to use the fact that I want the slope at this specific point 1. So I want you to get used to this notation. F prime of 1, that's going to be the slope at the point 1. So I'll get 12 minus 8, that's 4. So then putting this information together, I'd have y minus 2 is equal to 4x minus 1. So that would be the equation of the tangent line. One last one. So find the times. So the answer is going to be t equal number, maybe more than 1. The velocity is 0. So this means I want to say set the velocity equal to 0. I've got the position function, and you know one derivative gives me velocity. So I get 3t squared minus, I'm saying t, 3x squared minus 6x. And the derivative of that -4 is 0. So I'm going to set it equal to 0. So 3x squared minus 6x. Do not divide by 0. You would lose an answer. Let's factor out an 3x, so I'd get an x minus 2. So the times that the velocity is 0 would be 0 and 2.